about H bonding or hydrogen bonding, and just a couple of the things that you should be aware of when you're thinking about how hydrogen bonding can affect different aspects of chemistry. So the first thing that we're going to go over is just the principles of H bonding. So the thing to remember is that there's only 3 molecules that will ever H bond, and they are oxygen, fluorine, and nitrogen. So OFN, that's a really important part, and so basically you'll have H bonding to each of these, and this will really affect some of the principal qualities of different molecules that you're looking at. So the first thing we're going to talk about are your phase diagrams. So just as a quick review, when you're looking at a basic phase diagram, I have phase diagram of water and carbon dioxide up here. So this is solid, liquid, and gas for each one of them. So you'll notice the border along the solid and liquid phase, so right here and here, have very different slopes for both H2O and CO2. And the reason for this is, of course, H bonding. So when you're looking at phase diagrams, if you're at a solid temperature, if you increase the pressure, your molecule, the way you want to think about it is if you have just a solid, like a basic solution in a container, and it's at a solid temperature the entire time, as you start to decrease the size of the box, your molecules are going to want to pack down, so they're going to want to favor their more dense state. And so that's why you have the different slopes for your solid-liquid boundary. So as you start to decrease the size of a box just filled with carbon dioxide, its more dense state is its solid state. So as you increase pressure, you want to stay towards your solid side. But one of the principal things we all know about water is that ice floats in water, so obviously its solid phase is a lot less dense than its liquid phase. So as you increase pressure, you're going to want to stay towards your liquid side. So that's the reason why there's a positive over here, a positive slope over here for carbon dioxide, and a negative slope over here for H2O. And the reason for the difference in densities is H bonding. So that's basically how you explain that. The next thing that I want to talk about is boiling point changes. So as you add H bonding into the different forces among your molecules, it starts to really strengthen the connection between your different molecules in your solution. So it takes more energy to kind of separate different molecules from each other and excite them more and get them to actually boil. So you'll start to see a trend as you're looking at the boiling point of different molecules based on their period on the table, so basically how much they weigh going down the different columns on the periodic table versus their temperature, you'll notice that each of the molecules that can hydrogen bond will have a significantly higher boiling temperature than any of the other molecules in the same period as them. And that's simply due to H bonding. You can do the exact same thing if you do NH3 versus the other molecules in that period, and you'll notice the exact same trend. So your boiling point will fundamentally increase as you increase your temperature, your weight of your atoms that are participating in the molecule. But the other thing you want to definitely pay attention to is the fact that any of the 3 molecules, oxygen, fluorine, and nitrogen, that can bond with H will significantly increase your initial boiling temperature among that period. So that's basically hydrogen bonding. Hopefully that makes sense.